Good day to all the viewers. The session is regarding the intermediate chemistry, will be very much helpful for your international entrance and competitive exams as well. India is conducting JEE Advanced, JEE Mains examination to get the admission into IIT and NIT technical stream. NEET chemistry will be conducted across India, that is the medical admission domain. Telangana and Andhra Pradesh government organizations are conducting MCET exam for BTech entrance, BTech admissions. In addition, so many government job portals will be there. Government competitive exams will be conducted where general studies is the common question paper we can observe. Where general science is the content you can see over there. And the session what we are discussing is very much helpful there. Let's go with the question number 1. How the pasteurization is milk is changed the world order, right? Milk pasteurization is kind of life related application. So it is a lively application. We can say how this pasteurization of the milk can entirely change the world order. So everybody aware milk is extracted from the lactatory glands of so many kind of animal species, right? So without any proper treatment, proper kind of management, what happens, it is not possible to store the milk for a longer time, right? So that may be wasted, so that may be denatured, and that can't be stored for longer time, and denatured milk is not fit for drinking and even for consumption by means of any process, so that will be entirely wasted. In order to avoid that one, in order to go for the exports, and in order to maintain the quality of the milk for the longer time, there is a outstanding invention we can say, which is called a pasteurization of milk. Milk pasteurization is most important chemistry discovery we can say, and among all the scientific discoveries, it is the kind of very prominent in nature. In the 1800s, Louis Pasteur discovered the way to make the milk for the beverages. You can store for the longer time, right? So though milk is extracted from the living organisms, right, milk giving animals, it can be stored for the longer time because of the process called pasteurization. Because of pasteurization only, we can now avail the milk abundant quantity all across the globe, and you can import and export, can store and can preserve for the longer time without any damage to that quality of the milk. All you need to know about heating of that milk at optimum temperature and rapidly cooling down to the lower temperature, the process is called pasteurization. The maintenance of optimum temperature in order to heat extremely compared to our room temperature, it will be somewhat high only, and rapidly cooling down to the lower temperature, the entire process you can say it is the pasteurization. Today, pasteurization is essential for delaying spoilage of that milk because of microorganism action over there, right? So that may not become infectious one, that remains a same quality whenever we are taking milk from that animal species. Pasteurization reduces pathogens in a food, and not only this pasteurization applicable to this milk milk preservation process, rather you can apply for another food beverages as well, right? So this is a kind of sterilization process. You can remove all pathogens by means of sensitive heat treatment, thermal treatment process. This is a kind of sterilization process, and it used to protect the food without any spoiling by the detritus organisms and microbes which used to decompose all the food materials. So that it is a kind of revolutionary invention we can say, and it is the best invention recorded and accorded with the Nobel Prize, that is the most esteemed and prestigious prize all across the world for the recognition of outstanding inventions. And how the pasteurization is carried, the device is provided over, and this is the entire device which used to pasteurize the milk in the systematic order, and especially the optimum temperature to be maintained in order to kill all the pathogens, in order to retain all the useful microbes in that okay. So that is not whatever temperature mentioned on this thermometer above this 150 temperature, that is not susceptible for the heating, and that may kill all the enzymes and healthy organisms whichever present in in the milk so that the milk is not fit for drinking. If you are heating at the temperature 161 degrees centigrade, at the temperature the denatured milk you can achieve, that is not fit for drinking. And if you are reaching at 280, it is said to be a ultra pasteurization, where completely that milk all kind of whatever its content is there totally damaged. So this is we can completely avoid such kind of milk which is heated at 280. So up to this 150 degrees temperature, we can say it is a low and optimum temperature for pasteurization process. And in specific, we can say 118 degrees centigrade is the kind of more optimum temperature for milk pasteurization. This is the way the pasteurization process will be carried, and this is the kind of invention in the food industry which entirely changed the availability of milk and production of milk as well, right? Next, we entered into the question number 2 collected from Cambridge Assessment International Education. Complete the table which is provided over here, and the number of electrons, number of protons, number of neutrons. These are called subatomic particles in the atom. Whatever atom you are choosing from the entire periodic table, it is composed by electrons, protons, and neutrons. There is a variation in their number, right? But these are the essential components which present in the given atom of the given periodic table, right? So here only two are provided. One is sulfur and second is oxide ion. So for these two, sulfur and oxide ion, how many electrons, how many protons, how many neutrons to be identified? Two numbers already provided, remaining vacancies we need to fill up. So sulfur atomic number is said to be 16 and 34 is the atomic mass. It is provided as the superscript, right? So if you are taking oxygen, it is mentioned with the -2 charge, and the superscript is 18. It is its ionic weight is provided. It is the atomic number you can notice. Okay, so if this is the case, how many electrons, protons, neutrons to be identified? Always remember, in order to go for the protons, whatever atomic number, that exactly is equal to its proton number. So blindly you can write 16 is the proton number for sulfur, 8 is the proton number for oxide ion. So here 16 and 8 can be written. So proton number we will go with 16 is the proton number for sulfur, and 8 can be proton number for what oxide ion. After mentioning this proton count, move on to electrons. Always neutral atom if considered, only for neutral atom, whatever atomic number is there, same will be replaced, same will be repeated for electron count as well, because in the neutral atom, number of protons is equal to number of electrons. That's the reason why. So proton count is 16 for sulfur. Same way you can write 16 for electrons for sulfur as well, right? So in order to go for this oxide O-2, there is the case is different. So in case of this, when it is mentioned with -2 indicate two more electrons are present, both two electrons are excess. If you go with 8 as the atomic number, you have to add more 2 electrons to this 8, so that 10 is the total count of electrons, because -2 indicates 2 electrons are extra. In comparison to protons, you have to add more 2. That's why it will become 10 electrons over here. This is the way negatively charged ion can be mentioned with the number of electrons. And another problem is counting the number of neutrons. If you want to count the number of neutrons, atomic mass minus atomic number to be taken. It is the difference between atomic mass and atomic number. 34 minus 16, 18 is the neutron number of sulfur. 18 minus 8, 10 is the neutron number of what? Neutron number of oxide. So the 10 is provided for oxide, which is already given to you. Okay, so here the requirement of neutron count for sulfur is 34 minus 16, that is 18. This is the way entire table was deduced. Only the fundamental needed to be understood is whatever atomic number is there, that is exactly is equal to proton number. For neutral atom, proton number is equal to electron number. For anionic species, whatever charge is there, for the proton number you can add the charges so that electron number will come. In case of cation, whatever charge is there from that proton number, the charge can be subtracted so that you will get its electron count. In order to calculate its neutron count, atomic mass minus atomic number, so that difference becomes its neutron count. This is the way subatomic particles can be calculated either for neutral atom, cation, or anion as well. Okay, so we completed question number 2. For question number 3, this is collected from 2017 paper 1 question paper of JE Advanced. Okay, P is the probability of finding a 1s electron of hydrogen atom in the spherical shell of infinitesimal thickness dr at the distance r from the nucleus. The volume of this shell is 4 pi r square dr. Volume of the shell is provided as 4 pi r square dr. The qualitative sketch of the dependence of P on R is, P is nothing but probability of finding 1s electron. There is a spherical shell is given by D. So P means the probability finding 1s electron, right? So this is called orbital that is taken on y coordinate, and R denotes what? Radius. R is the nothing but radius that is taken on the x coordinate. If that is the case, in case of 1s electron of hydrogen atom, 1s electron, always 1s orbital is known to be spherical in a shell. Spherical shape orbital will be there, and whose infinitesimal thickness is denoted with the dr. If this is the case, what will be the graphical representation? In order to explain this one, we have a distance from the nucleus called r. So that orbital distance from the nucleus can be taken on the x coordinate. And what is the probability of finding the orbital? Probability of finding the electron, probability of finding electron is mentioned with p, no? So that p can be taken on the y-axis. Okay, so in this condition, 1s orbital, being 1s orbital is very closer vicinity towards the nucleus, so that it is mentioned with this 1s orbital at the origin. And 2s orbital is somewhat apart in comparison to 1s. 2s orbital somewhat apart to the nucleus, so that it is a 2s orbital. If you move on to 3s orbital, it is mentioned with the first amplitude of light, second amplitude of light, third wave amplitude is mentioned like this. So this small amplitude denoted for 1s, and this is for 2s, and this is for 3s. 3s orbital somewhat far apart in comparison to 1s and 2s. This is the way radial probability is mentioned, and how the radius is related with the probability of finding the electron is mentioned. So if you go with 1s orbital, 1s orbital is denoted with this kind of curvature that is exactly mentioned in the option number D. This is the way question number 3, option number D is the correct answer for probability of finding the electron in 1s orbital is mentioned with the option number D. Move on to question number 4. Question number 4 is collected from the inorganic chemistry section, and in specific 13th group elements and in specific periodic properties. The increasing order of atomic radii of following group 13 elements are. Group 13 elements are denoted as a boron, aluminium, gallium, indium, thallium. All these are the part of group 13 elements. So among these, only the elements started with aluminium, gallium, indium, thallium, 4 elements atomic radius to be compared. Right. In general, what is the general trend of atomic radii in any atom? Atomic radii from top to bottom gradually increases as the number of shells increases top to bottom. In the boron atom, you can find 2s and 2p orbital, but in case of aluminium, 3s and 3p will be there. Gallium, 4s and 4p, indium, 5s and 5p, thallium, 6s and 6p. This is the way new shells will be added if we are descending down the group. That's the reason why generally, as we are descending, what happens? Atomic radius gradually increases. That will be the general trend. But there is an exception for question number 4. You are expected to be gallium, aluminium, indium, thallium. This is exceptional kind of relation you can notice over here. largest radius is accorded for the thallium, later on indium, later on aluminum, later on gallium can be mentioned over. That is quantified. So if you go with this empirical radius, so this is in the right order as the trend is moving. Aluminium, gallium, indium, thallium, this is the kind of group arrangement from top to bottom. So empirical radius gradually increasing, this is the natural trend only. If you go with the calculated one, so 118, 136, 156, 156 will be there, again it is the increasing order. If you go with any other kind of representation of the radius, van der Waals radius, we can say 184, 187, 193, 196 will be there. But actually the requirement is covalent radius is the measure of bond distance when two atoms are in the covalent bond formation, right? So in that case, so the covalent radius, if taken into the consideration, aluminum quantification is given as 126, gallium is given as 124, indium is given as 142, thallium is given as 144. If you observe, 124 covalent radius of gallium is least in comparison to aluminium, aluminium followed by indium, indium followed by thallium. This is the right representation of magnitude of atomic radius. Gallium is least, followed by aluminum, indium, and thallium. With respect to the covalent radius, this order will be provided. And that is only given for the atomic radius in picometers. That is given in the option number B. For question number 4, option number B is the correct answer. Move on to question number 5. Question number 5 is collected from atomic structure in the hydrogen atom. The minimum energy required to excite the electron from second orbit to the third orbit, right? So as already we aware that only hydrogen atom is having one electron. That one electron, if it is staying at the 1s orbital, that is said to be a ground state around that hydrogen atom. But they are saying that second orbit to the third orbit, it is jumping. At that condition, what will be the minimum energy required for the excitement? And it is mentioned in the electronic volts. The expected answer is 1.9 electron volts. So let's see how can we get the calculation part over here. According to the Niels Bohr calculation of atomic model for the hydrogen atom, Niels Bohr gave the hydrogen atom atomic model, and energy of the electron, if electron is resided in the nth shell. If electron is present in the nth shell, then it is energy is given by minus 13.6 z square by n square. E for energy, z for atomic number, n for in which shell electron is laying, in which orbit electron is laying, that orbit is given by this n. Energy required to excite the electron from initial to the final state. So how much energy is required, that is taken by the difference, that is called what? Energy of final orbit level minus energy of initial orbit level can be taken. Energy is equal, total energy is equal to energy required is equal to energy of final minus energy of initial. Final energy, they are saying that final energy is the third orbit, initial energy is the second orbit. So that let me put in this formula, minus 13.6 remains as such. Z means atomic number, being it is the hydrogen atom, atomic number taken as 1, you can put 1 square by final energy level is the third one, so 3 to the power 2 can be mentioned, 3 to the power 2, so this is 3 to the power 2, and final minus initial, so that put the negative sign over there, and again we have to repeat the same for this initial as well, right? Initial energy is given by minus 13.6 into 1 square by this n. Initial energy level is taken as the second orbit. So the 2 to the power 2 can be taken. Okay. Minus 13.6 into 1 square. 1 square will become 1 only. Minus 13.6 into 1 means minus 13.6 only. Minus 13.6 by 3 to the power 2 means 9. So if you are taking this calculation, that will be minus 1.51. The value will be minus 1.51. Here, if you observe negative into negative, that will become positive, right? Negative into negative will become positive. Then 13.6 into 1 square by 4. Plus 13.6 by 4 means 3.4. So 3.4 is the positive value. minus 1.51 is the negative value, so that you can go for the subtraction. If you go for the subtraction, the difference is 1.9, and being larger value is accorded with the positive, so that you can put the positive sign over here. And always energy is mentioned in a electronic volts. 1.9 electronic volts is the correct answer, that is achieved in the option number 3. For question number 5, option number 3 is the correct answer. Move on to question number 6, the last question of the session. The velocity of de Broglie wavelength is given by. So velocity of de Broglie wavelength to be calculated. So in order to get the de Broglie velocity means v. Wavelength means lambda. There is a difference in the velocity and wavelength. You have to keen about the question, how the question got framed. The velocity v of the de Broglie wave is given by. So here the terms which are provided, nu is equal to frequency, m is equal to mass, c is equal to velocity of light. These are the terms which are present in the formula, then only they will give the data, right? So that you can put mc square may not be correct, nu and lambda may not be correct. H nu by mc is the correct answer. C square by v is not correct. For question number 6, option number 3 is the correct answer. Let's see how can we get this. De Broglie equation is given by lambda is equal to h by mv. Lambda is mentioned as the wavelength in meters. H is the Planck's constant, everybody aware about, and m is the mass in kilograms. Nu is the v is the velocity of the light in meters. Velocity of the light in meters can be taken. Okay, so this is in the form of lambda is equal to h by mv. If you want to calculate this v, means we need to calculate velocity, right? Velocity is equal to h by m lambda, it will be, right? If you rearrange, if you substitute the value of lambda over there, the value will become hv by mc. De Broglie hypothesized that any particle should exhibit duality. Dual nature of the light or dual nature of the electron is explained by this De Broglie concept, right? So here duality is nothing but light or electron is having the nature of wave, nature of particle as well. The velocity of the particle is always is equal to velocity of corresponding wave. So what is the wave speed is there, that is equal to velocity of the particle as well. Thus the velocity of de Broglie is given by hv by mc. Okay, so h nu by mc will be there. Nu means what? Frequency. H is the Planck constant, m is the mass, c is the velocity of light, that is provided in the option number 3. By this we entirely completed the session, and the most critical concepts are discussed over here, and the problematic session is clearly demonstrated for your convenience. Definitely you will get the good score if you are following in the serious manner whatever sessions we are conducting. I'm sincerely requesting to like the channel, comment. In order to comment, we have a question over here. In case of dual nature of electron, what is the concept which is strongly agreeing with the particle nature of electron? Let me repeat the question. Particle nature of the electron is strongly justified by which concept? That to be mentioned in the comment box, and share with the aspirants who are serious about the examination, and subscribe the channel to receive more updates and more such kind of content in the near future. Thank you one and all.